So thank you all for joining me today. Looks like my clickbait title actually worked. We got a pretty good amount of people here, so excited to see that. I'm super, super passionate about performance, and I look forward to chatting with you about it today. You're probably sick of seeing this slide already, but if you do get a chance, please fill out the session survey. It really helps me understand, like, is my job worth doing? Should I be coming here? Should I be talking to all of you? And so with that, who's this guy that's talking to you? I'm Nick Karpinsky. I have been in Visual Studio Diagnostics for 10 years, my entire time here at Microsoft. I am the lead for the Performance Profiler team. And over this time, I've worked with numerous teams and customers inside Microsoft, outside of Microsoft, to go and improve the performance of their applications. While doing that, I've worked with my team to help build in more insights into our tools and to make them easier for developers to use so that you can get insights about your application and then improve the performance of your applications. And so today I wanted to kind of chat with you about the trick that I've learned over my 10-year tenure here at Microsoft. But before we get started, who here has used the Visual Studio profiling tools? Anyone? Oh, I'm seeing a couple of hands. Awesome. Afterwards, come talk to me. I'll also be in the Ask the Experts. I want to hear about your experience with the tools. I want to hear about what you liked about them. Uh-oh. And what you don't like about them. I want to hear about any of the performance wins that you've gotten. It's super, super interesting to me. It's super interesting to my team. Who here hasn't ever used the profiling tools? Oh, yeah, I'm seeing some hands. I also want to talk to you, and I want you to tell me about how you're going to go and change your ways, and you're going to use the tools, and you're going to get better performance for your customers. And so now, because clickbait titles do work, the question on everyone's mind is, what's that one weird trick to get better at performance? The trick? You honestly just measure it. Seriously, that's it. Talk's over. Questions? No, I'm just kidding. I got like 100+ slides to go. But if there are 100+ slides to go, I've already given you the trick for, hey, you just go ahead and measure it. What am I going to sit here and talk to you about? Hopefully it's not my terrible stand-up improv. No, I'm actually going to walk you through using the tools, and we're going to try and improve the performance of stuff together. I want to show you that you can take basically any piece of code, you can run through the tools, and you can measure, you can make meaningful changes, you can measure again, and you can see that performance improvement. And so Visual Studio has lots of tools to help you with this, and I'm going to share those with you today. This talk is really a walkthrough format. So your mission after this is go to the conference website, go download this talk, and walk through it afterwards. Do you get the same results that we get during this talk? Do you not? Encourage other people in your organizations to go walk through this as well. Try and build up that performance-focused culture, because it's really going to help make your customers happy. It's going to help you reduce costs, and it's just going to make you a better developer. And so with this talk, I'm going to leave you with a couple of skills. The first one I want to leave you with is benchmarking. And once you start establishing these benchmarks, running these tools becomes easier and easier. After we get you with some benchmarking, we're going to show you how to use the CPU usage tool to improve your overall CPU performance. And then we're going to show you how to use the .NET Object Allocation tool to improve allocation performance in your applications. And so with that, let's go ahead and get started. Who here has written a benchmark before for any of their code? Anyone? Couple of hands, couple of hands, couple of hands. Awesome. These benchmarks are great. I like to think of them as like a unit test for performance. And so when you think of benchmarks, debugging is to unit tests as profiling is to benchmarks. They're just a great kind of artifact that you can add to your code to help you measure performance and make systematic changes. And much like debugging, you don't just randomly attach a debugger to production apps or hope that you catch something. Well, at least not if you're not having a good day. But once you have these, similar to unit tests, you can help catch these regressions. And so you can also use them to measure changes that are happening outside of your application. Let's say you're updating a dependency in your application. You're taking a new version of .NET. this really helps you see what are the benefits to taking this change. And so with this, I set myself a challenge in this talk. I really dislike talks where people have some sort of toy application, they profile it, and they show you like, oh, hey, I shouldn't have used the slow CPU method, I should use the fast CPU method. Those sorts of talks are just, they're not super helpful. And so I want to give you access to code that you can play with and you can benchmark and you can improve. And so I went ahead, I went to our favorite package manager, NuGet.org, and I went to the statistics and I searched for what are the most downloaded packages. And as I scrolled down, I was determined to find a package in the top 100 that I could then take, write a talk about, and hopefully inspire all of you with. And so as I started scrolling down, I saw the CSV helper package. I have not used this package before. It's in the top 100. It's used by, the current version is 10 million plus downloads. And so obviously this is a well-used package. It has probably been optimized. It's going to be a little challenging to try and find optimizations in it. But I'm confident using the tools in Visual Studio that we're going to be able to do this. And so what did I do? Of course, I click on this, takes me to the GitHub. And like all good software engineers, I want to take this code, I want to go ahead and I want to play with it. So I grab that, switch over to our console, we clone it into our workspace, we get it pulled down, we change into it, and we launch it in Visual Studio. And so now when I get into this project, again, I've never used this project before. I pulled it from here just for this talk. I want to try and make this faster. And what's really nice about this project is that it already has this product project and it has this unit test project. And so if I look up here, I see CSV helper, I see CSV helper.tests. Tests can work as benchmarks. I don't always find them quite as accurate because a lot of times in tests, you're trying to mock stuff out, you're trying to verify assumptions. You know, does this method throw argument null exception when I pass in null? I don't really care about the performance of that much because there's not a whole lot I can really do to it. If you do happen to have tests that really exercise your code from end to end, you can use those as benchmarks. We on my team do that. We have tests that do full end-to-end integration. We use them as benchmarks, and they're a great way to test the performance of our application and see, how long it takes to run stuff. But in our case, these tests are mainly spec tests. So I want to go ahead and I want to add a benchmark project to this. And so I'm going to go ahead, I'm going to right click on solution, I'm going to add a new project type. As you can see in my recently added projects, I'm constantly adding console applications everywhere because I'm an engineer, I like to play with stuff, and I want to see how this works. So I go ahead, I add this console application. It's a CSV helper benchmarks thing. We'll go ahead, we'll use .NET 8. I personally don't like top level statements a whole lot, so I'm going to disallow that, and I get this console application. And so now that I'm here, I have this project I don't know about, I have a benchmark. The only other thing I got to do is quick add a project reference over to the library, and now I have all the makings to start writing some benchmarks. So I have this console application that runs, I can run it in Visual Studio, I can add code, and I can sit and test and fiddle and really start to understand this library. And so now that we're at this point, what do? We need some sort of code that we can go ahead and test with this library. And again, I know nothing about this library. Turns out they have great documentation, which is awesome. So I see all this, and this looks great. I take this, I copy it into that project. And so you can see now I have my console app. It's creating this new benchmarks class. It is calling this read large file. Read large file is literally just that code copied and pasted from the web. And now I just need a CSV file. So we go to our favorite search engine, search for large CSV. I find this gross domestic product for New Zealand. I have no idea what this data is. I don't really care. I just want to get some data that I can start analyzing. So I bring that into my project. I add a reference to it and say copy it to the output directory so that I can go ahead and run it, change my code a little bit. And then the last thing I have to do is, if you look at this code, we instantiate a stream reader. we pass it into the CSV reader thing that goes ahead and parses our records. We need to tell it what the shape of one of these records is. And so this is just big block of code. You can copy it when you all go and pull this presentation down later and try this for yourself. But this will let us parse one of these lines. And then from here, I'm at a state where I can actually run my code. So I hit F5 in the debugger. No exceptions blow up at me. I don't see the exception helper here. I see exited with code 0. That's awesome. So now we have an actual benchmark. We can use this little program to go ahead and improve the performance of our application. From this point, I could sit and I could run this under the performance profiler. I could use all the various tools, and I could improve the performance of this from here. But we have some tools that are outside of Microsoft that actually help make this better. So anyone here ever use benchmark.net? Heard of benchmark.net? Ooh, couple of hands, awesome. Let's go ahead and install that. So I'm gonna right click on my project. I'm gonna manage my NuGet packages. Benchmark.net, you can see it's got 31.3 million downloads, more than our CSV helper. Super popular package. It is a great, great piece of software. So I'm gonna go ahead and I'm gonna hit apply, and I'm gonna install it. And now that I have this installed, I need to change my console app from a console app to a benchmark. And so what I do is I add this benchmark attribute onto this method for this read large file. This is going to tell benchmark.net that this is a benchmarking method and that this is what we want to try and measure. And then in main, you can see I'm no longer instantiating my class and calling that method. I'm instead using this benchmark runner.run benchmarks. And what this tells benchmark.net is this is my benchmarking class. I want you to go ahead and I want you to instantiate that, and I want you to run that as my benchmark, and I want you to calculate all my statistics on this. And so from this point, I can go ahead and I can hit run, and it all blows up on me. This is awesome. Benchmark.net is actually helping us here because it knows that when you're profiling, you want to profile in release bits. You want to profile the bits that your customers are actually going to get. And so in this big block of red text, it's telling you like, hey, you're not using an optimized version. This is super important. You need to use optimized versions, otherwise you're not going to get good data. So back in Visual Studio, I flip over to my release bits and I run it, and boom, I get some statistics out from benchmark.net. And so when you look at this, you can see like we've got some system information. You know, I'm running on a 16-core machine. And then it gives me a list of all my benchmarks and then how long each of those benchmarks took to run. And so you can see my read large file completed in about 131 milliseconds. It had 2.5 milliseconds for error and about 2.5 milliseconds for the standard deviation. And the nice part about this is I can run this and I can start making systematic changes and I can see the effect of those. And so at this point, we've got a benchmarking project. We're all set up. And so like I was saying, we can use this to systematically measure the impact of changes as we go ahead and make them. And so what's the next question that should be in everyone's mind? Anyone? When the next coffee break is? No. The next question that should be in your mind is, where should we start making our changes? Because right now we have this benchmark that's going to tell us like, hey, this took 131 milliseconds to run. I could look at this code and I could start guessing at different areas where it's like, I might change this, and I can rerun the benchmark and I could see like, hey, did this actually help me improve my application or did it not? But that's not a really efficient use of my time. I instead want the actual data that's going to tell me like, where should I focus my investigation? And that's where Visual Studio is really going to start to show and shine here. And so the first thing we're going to look at is CPU usage. And so now that we have this benchmark.net benchmark, how do we go about and get detailed performance data on this? You could try and profile this benchmark with the Visual Studio Profiler. Benchmark.net takes your benchmark, it compiles it, runs it in its own child process to try and eliminate overhead from other things that are running in your system, this is going to make it a little bit difficult to run it under the profiler. So recently, my team added a new NuGet package that's going to help you with this. And so again, we're going to go ahead, we're going to manage our NuGet packages. We're now going to search for Diagnostics Hub, this benchmark.net diagnosers. I promise this is in our documentation online, otherwise I'd never be able to find it. But from here, we're going to get this window. I'm going to hit apply. I'm going to accept the license. And now we have the Visual Studio benchmark.net diagnosers installed. And so now that we have that installed, we can add this CPU usage diagnoser into our benchmarks. And what this is going to do is this is going to basically tell this benchmark, I'm interested in collecting performance information. Please reach out, tell the Visual Studio profiler to profile me. And so benchmark.net diagnosers for benchmark.net are a way of capturing additional performance information on a benchmarking run. And so benchmark.net, I think, has a memory diagnoser that tells you about like allocations. It has an ETL one that does something similar to this. I think it has one for concurrency visualization. But this one is specific to the Visual Studio profiler, and it knows how to talk to us, and it knows how to go ahead and capture one of these traces. And so if I go ahead and I run this now, again, I get this very similar output. I got my system settings on here. I have this block that shows me each of the benchmarks that run, and it says read large file. It took 132 milliseconds. This time the error rate and standard deviation's even less, which is awesome. I keep scrolling down. I see this diagnostic output, VS Diagnostics Diagnoser. That's that benchmark.net diagnoser that we just added. And if you look closely, it'll say collection result moved to blah, 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 diag session, and gives us an exported diag session file. For those of you that haven't used the VS Profiler yet, diag session files are our format of choice. It's basically a nice package format that captures all of the stuff that we need, makes it into a nice, easy file for you to send to your friends and analyze. And so with this file, we can now see where was time spent in our benchmarking run. Unfortunately, we don't have the ability to automatically open this in Visual Studio quite yet. We are working on that for 1712. So you're going to have to hit Control-O, and you're going to have to manually open the benchmark file. But then once you do, you're going to be greeted with our Visual Studio profiler page. And in this first page that you're going to see this benchmarks tab. And so this benchmarks tab really just has that same information that you saw on the console. So it's got that start time and end time. It's got the mean, it's got the error, it's got the standard deviation. We also get just a little bit extra information that it didn't show you on the console. We tell you the number of iterations that your benchmark went through. So benchmark.net runs your benchmark multiple times. So it tries to generate some nice statistically significant data. We'll record that, and then you'll be able to see that and know how many times it was running. From this point, I'm going to double click on my benchmarking line, and it's going to go ahead and it's going to set a time selection in the profiler. For those of you who haven't used the VS Profiler before, this time selection up above in our graphs allows you to basically filter results to whatever it is that you're selecting, and it allows you to really dig in and start to investigate. And so in this case, we're saying, I want to investigate this read large file. And so next, I'm going to switch over to my CPU usage tab, because that's going to tell me where I want to spend my time investigating. And so, like I was saying, there's a couple of different pieces to the profiler. This top piece is the graphs. Depending on the tool that you're running, we're going to show you different graphs. In this case, we're running the CPU usage tool. So, of course, we're going to show you a CPU usage graph. Later on, you're going to see the .NET allocation tool. That's going to have some memory and allocation graphs. We have other tools. We have an events tool. We have a database tool. Basically, all the different ones you can possibly think of, they're going to have graphs corresponding to the different things that they're trying to measure. Down below, we have our summary page. We have our top insights. These in this trace right here, we don't have any top insights because, like I said before, this is a very popular code. It's probably pretty optimized. There's nothing that just immediately pops out to us. If you do see one of these top insights when you run the Visual Studio Profiler on your code, on your benchmarks, you probably want to listen to it. These are bad performance patterns that we've seen from lots of customers over the years. We've just gone ahead and codified them. And so when we see that pattern, we're going to call it out and say, like, hey, you should go do this. You should go fix this thing over here. It's probably really going to help you. You also see an Ask Copilot button. We're going to talk about that a little bit later. You can ask Copilot for insights as well. Moving on, we have our top functions. And so top functions show you where time was spent in your program by the amount of CPU resource that was used. And so you're probably thinking like, hey, Nick, what's a CPU resource? So our CPU usage tool works by CPU sampling. So every so often, we are going to ask your program, where are you at right now? And so we're going to use that information to figure out statistically, where do you seem to be using the most amount of time? This is called sampling. And so our unit here is really samples per second. And in this case, we sample at, by default, 100 samples per, or 1,000 samples per second. And so you can kind of fuzzy think of this as like, this top row is 3.8 seconds. It's not 100% correct, but it's close enough that it'll get you there. And so you can use this number to really see where am I spending the most amount of time. The other two things you're going to see here are total and self. Total time is the time spent by this function and all the other functions that this function calls. And self is really time just spent in that function. So you can imagine, like, if you're doing a bunch of math or string manipulation inside a function, that's probably going to get bubbled into self time. And then whatever called that function, that time that was in that will get bubbled into that thing's total time. Moving on, we also have the hot path. So up above, we had top functions. Down below, we have hot path. Top functions are the functions wherever they show up in your program. And then the hot path is, if we take all those samples, we put it together in a call tree, what is the one path that seems to be taking up the most amount of time? And so in top functions, you can sometimes see like logging might show up. And while logging, a single call might not be all that expensive, as it adds up throughout the call tree, it can get a little bit more expensive, and that's how it could bubble up into a top function. The hot path is going to show you really where is that most amount of time being spent. And so if we look, we can see this CSV helper, CSV reader dot read makes perfect sense. We literally just created a benchmark and collected data on how long it takes to read and parse this CSV file. And so I would totally expect that to show up here. Now, all of those functions that you saw on that summary page, they're all hyperlinks, and they link to the various views that we have in this tool. So that was the summary page. This is the details page. This is going to show you more specific details on what is actually happening. The first view here is the call tree. Anything you click on in the hot path will link you to the call tree. And you can see it's already gone ahead and it is highlighted this read path because that's what we clicked. And so you can see the hot path that goes down to that read. And then that read is one of the hot items. Down below, we do this thing called source line highlighting. We're going to show you the source of your code that you've been profiling. We're going to overlay the profiling data on top of it. And so you can see exactly which lines were the expensive ones. And that's where you should really start to focus your investigation. I am pulling one over on you just ever so slightly here. Our benchmark.net scenario doesn't quite yet support source line highlighting. So I went ahead and I ran this as a console application 50 times. And I'm showing you that trace right here. We should have that fixed for 17.12. It's a bug we're working through right now. But I don't want to lie to you. Now, once we're in our views, we also have this super, super handy feature called cross-referencing. And so you can be in a view and you can look at that same item in another view. And doing this really starts to help you see your functions in different contexts. And so I was saying before, like sometimes you have like logging functions, which won't necessarily show up in a call tree, but they might show up in a functions view, or something might show up in a functions view and it's only in one spot in your call tree. You can jump to them with this cross-referencing. So right here, I've right-clicked on read, and I want to see that read in the modules view. I can click on that, and it's going to take me to the modules view. And so modules are, we take all of that profiling data and we aggregate it by process, then by module, then by function. And so in this case, you can see the benchmarks had called a CSV helper DLL, and then that called that read. And so anywhere that read showed up in the call tree, we aggregated together and we show as a node here. We've got a couple other views you can just switch to using the current view. We have a flame graph, just like almost any other profiler. In this configuration, some people would argue with me that it's an icicle chart. There is a little button up top that you can hit flip flame graph if you're so inclined and you have to see stuff from bottom up. I like it top down. We also have this caller callee view. And the caller callee view is going to show you what is the call graph. You can click on these boxes and you can use that to kind of navigate the call graph, and you can see, like, based on my current function, who's calling me, what am I calling, and you can use that to try and improve your performance. So that is the whirlwind tour of the CPU usage tool. Let's go ahead and let's make some stuff faster. So we have a benchmark. We have this trace that tells us where time is being spent. We have all the pieces to try and make us successful. And so now I'm back to the trace where I ran this on the actual benchmark. Like I was saying before, we don't support source line highlighting yet with the benchmark ones. So you'll see this on the bottom. And when I start looking at this trace, I see my read large file, which makes sense. That's my benchmark. That's the thing that was doing or spending all of the time. The next thing I see is this get records. I can see the total time is 95% of my time, but there's very little self-time. So I'm going to keep kind of going down this hot path. I see this CSV helper CSV read, which spends 61% of the time and doesn't have a whole lot of self-time. And then there's like this horrible dynamic Lambda method. I don't want to play with that. I don't know what that is in this library. I'm going to give up. But let's go ahead and let's expand read. And so in read, I can see there is the CSV parser read line. Seems to be spending about half the time. And then there's this fill buffer that's spending, I don't know, 15% of the time. Fill buffer seems kind of weird. Let's go ahead and let's see what that is. I see a stream reader span. I see a memory move. Looks like this is the thing that's actually doing the file reads. I don't know, it looks a little weird. Let's go ahead and let's just take a look at the code. And so with this, I jump over to the code and I can see, here's my fill buffer. Don't forget the async method below. That seems interesting. We'll come back to that later. It goes ahead and it calculates this characters left thing. It does this weird array copy. And then this highlighted part is where it's actually reading the buffer. And so this buffer is the actual file buffer that I was passing in before. So really not a whole lot I can optimize with that. But that thing you see above is like, oh, that's really interesting. Don't forget the async method below. So from here, I'm going to scroll down a little bit and I see this async thing. And I wonder if we could use this async version to try and enumerate the records async. I bet that's what would call this fill buffer async. And for all of you .NET developers out there, we all know async is free perf, right? Yes? And so let's go ahead, let's go back to our benchmark. Let's change this to be async. Sure enough, there is an async version of get records. It's going to return an async enumerable. And we can update our benchmark to now be an async method. It returns a task. Benchmark.net knows how to handle async, so that's awesome. And remember, we're systematically making changes. We're going ahead, we're measuring the impact, and then we're digging in from there. So we've made the change. Next spot is measure. We go ahead and measure, and boom, 161 milliseconds. And at this point, you think, and good going, you idiot. You made it slower. That's the exact opposite of what this talk is supposed to be doing. And so it's actually slower, and that's weird because everyone I've ever talked to has told me async means free perf. But it actually makes sense that it's slower because we're doing more work with async. We actually have to manage async state machines. We're waiting for async tasks to complete versus just screaming along on a single thread. There's like this thread pool that we're queuing stuff on. So it's a little weird. I could revert that change and I could try and optimize other ways. But if you think about it, moving over to this async version isn't too bad because we did get one benefit here. And that benefit is we're breaking up that processing that we're doing. We're no longer burning on a single thread. We're breaking it up into different chunks. And so imagine if you're on some web app, other tasks get a chance at that CPU resource. They can hop in. They can take advantage of the fact that, like, hey, there's a little bit of free time. There's other tasks that are queued, but I'll be able to make process. This is a great way to kind of help with responsiveness in your applications. And so now that we have this kind of async version and we can help with responsiveness, let's see what we can do to try and improve the performance here. And so immediately after running my benchmark, I still had that CPU usage diagnoser on there, which means I get another diag session. I open that diag session. I use the benchmark thing to go ahead and set my selection. So I filter down into that. I'm now seeing in my top functions, there's a bunch of these system private core lib, blah, 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 blah. That's really weird. That actually is just a bunch of cross-gen .NET modules. I don't really care about that. Don't know why it's there. We'll just ignore it. But I do see my CSV parser.readline. And so let's go ahead and let's jump back to the call tree and let's start digging in. And as soon as I start looking at this, I get my process. I see my fill buffer async, which then calls read async, that calls read async, that calls get records, that calls read large file. Like, wait, this makes no sense here. Like, my benchmark was the thing that was calling this code. Why is it showing that this code is calling my benchmark? Anyone know the answer here? Async task continuations. This makes stuff super challenging for performance investigation. But basically what's happening here is your code is going along. It's going super fast. It gets into that first async thing where it actually has to go ahead and read that buffer async. It is then getting queued over on the async task queue. Once that buffer gets filled and we can finish our await, it calls the next thing in the async continuation, which is actually the second chunk of read async, which is then going to call the next chunk of get records async, which is then going to call the next chunk in your read large file that was your benchmark. And so async makes performance investigations a lot trickier, but you can still get through it. And so let's set that aside for a minute and let's instead look for our file stream read, because we know that we're still reading from the file and we can use that to figure out where our time or how much time we've been spending there. Okay, what the hell? I switched my code to be async. It got all weird. Now I'm not even seeing my file stream read anymore. What's actually happening here? Anyone have the answer? So the CPU usage tool reads CPU time. It doesn't read actual wall clock time. And this is one of the biggest takeaways that you should try and remember when using this tool. So by flipping to async, we're actually missing out on basically gaps of time that might be happening where nothing is happening on the CPU. What's actually happening is we've said, please go off and do this work. In Windows, if you're doing a file read, this is a deferred procedure call. Later on, it's going to call back and say, hey, I've got your stuff. Here you go. Which means this file stream read, you're not going to see it in this trace. But that's okay because we know that this was happening back when we converted over to the async version. We know that it went ahead and it extended the time. So now let's go and let's see what further optimization can we do here in this fill buffer, because we know fill buffer is taking time. We know that it's doing some sort of async IO read. What can we do? And so here is this code for this fill buffer async. And as I start scanning down, there doesn't seem to be a whole lot that I can change, except for there is this await reader read async. And so what's happening here is we're entering into our code, we're going ahead, we're reading a bit, and we're going to hit an async point where we're saying, please go read this thing from disk. When you're done reading it from disk, come back here, let me know so that I can continue processing. And that gets me thinking, what if we could go ahead and we could read this ahead of time on potentially another thread pool thread, and then when we need to go and ask for it, it's already ready for us. And so let's go ahead and let's write that code. We can be nice and messy because, again, we're just trying things out. We're experimenting. We're measuring, we're changing, we're measuring again, and we're trying to see the impact of this. And so I'm going to add this async read ahead buffer, and I'm going to add this read ahead task. And so what this is this is going to be the task where we're going ahead and we're reading. We're going to have a temporary read ahead buffer that we can read into so that when we're done, we can just swap it with our existing buffer. And then this previous characters left, just because we're reading the thing ahead, we need to know the characters down below, the characters read that we got last time, so we can return it to the CSV helper state machine. Not super important. So I'm gonna go ahead and I'm gonna change this code a little bit. This first thing is it's checking to make sure the thing that it's reading in, the buffer that we have, is large enough. I'm going to go ahead and assume we never need to expand that buffer. I'm going to leave that as an exercise for the reader because I'm super lazy. The next thing I'm going to do is, if I don't have my read ahead buffer, that means that's the first time I'm entering in here. I'm going to go ahead and I'm going to instantiate that buffer, and I'm going to kick off that read ahead async task. Now let's fold this code away. And now let's just look at this. Characters left, we're doing an array copy. I'm not really sure what that is. And then we're calling this read ahead async. So now, what is this code doing? What's happening here is, in this code, we are saying, I want to array copy buffer row start position to buffer position 0, the number of characters that we have left. And so what's happening is we've partially read into the buffer, but we need more data from that file before we can read any more CSV data. So what it's doing is it's copying this block, it's putting it at the beginning, and then it's buffering in the next amount of text for us to read. Now that we have this read ahead buffer, this gets a little more complicated. So we do a little maneuver I like to call the read ahead shuffle. We have our read ahead buffer. Assume this is full. We have our actual buffer that we've read up to a point, and we need more data in. We're going to take what was in our read ahead buffer at the tail end that matches what we have remaining in our buffer. We're going to switch it to the beginning. We're going to shift the stuff in the read ahead buffer to the end. We're going to take the stuff that was at the end of our buffer, move it to the read ahead buffer, and then we're going to swap the buffers, and we're going to go ahead and read stuff in. And so it's a little complicated. Like I said, download this presentation, walk through it yourself, play with this a little bit. You'll kind of see what's going on. When we go back to the code, this is what that actually looks like. You can see we're doing 3 different array copies. We're shuffling stuff around. We're actually going to be doing more work, but we have the potential to make things faster. Let's fold that out of the way, and we're almost at the end of this function. Now that we've gone ahead and read the async buffer in, we do the little buffer swap. And then at the end, instead of calling await reader.readAsync, we're going to say reader.readAsync. We're going to hold this in a task, and we're going to come back to this later. And so what this is really doing is this is saying, I need whatever you've previously read ahead into my buffer so that I can analyze this. And then while I'm going ahead and I'm analyzing stuff, go off and fetch the next chunk of the data so that when I get back here the next time, I'm ready right away. And so this is the huge block of code. I only put this in the presentation so that you can copy and paste this into the solution when you're done. But now we've gone ahead, we've made a change. And so what do? We measure, we make a change, we measure again. I run this code. This was previously at 155 milliseconds. This is now down to 130 milliseconds. We are beyond the standard deviation, so we know that this is objectively faster. In fact, it's 16% faster. And so this is awesome. This is where everyone should be cheering. We've gone ahead, we've taken code that's randomly off the internet, we've made it faster. We're about the same speed as the single-threaded CPU case, but in this case, we're actually doing it async, which means other things can tag in, and we can share that CPU resource. So this really helps make your apps stay responsive, yet fast. So this is awesome. The next thing I want to talk to you about is .NET allocation. So we've gone ahead, I've showed you how you can use the CPU usage tool, you can go and improve performance. Now let's go and let's use the .NET allocation tool and let's go improve performance there. And unfortunately, we don't have support in benchmark.net for the .NET allocation tool quite yet. That is also coming in 17.12. So instead, I got to change my code a little bit. I'm going to take my CPU usage diagnoser away. Instead of using the benchmark runner.run, I'm going to comment that out. I'm going to instead just instantiate the benchmark, and I'm going to go ahead and I'm going to call read large file. And so what this is going to do is, instead of having a benchmark, we have a console app again. All it's going to do is it's going to zip through this file, and we can go ahead and analyze this with the performance profiler. So I'm going to go to debug. I'm going to go to the performance profiler. These are some of the various tools that are in the performance profiler that help you analyze performance of various facets of your application. I'm interested in object allocation, so of course I'm going to click that. I'm going to hit start, and I'm going to see this page while it's collecting. What this tool is doing is every time you allocate something in .NET, we are recording that allocation. We're recording the allocation type. We're recording the allocation size. We're recording the allocation location. This thing is super, super expensive. And so if you look back here, when you select this tool, we automatically say, you don't get to select any other tool because this is going to skew all of your data. But it's super, super helpful for tracking down where you're actually allocating stuff. And so after I go ahead and collect, let this run for a little bit, I get to this screen. Like I said before, each tool has its own set of graphs. This one has memory-specific graphs. The top one is showing you the number of live objects. So even in this small application that is just reading stuff in, and I am literally chucking the records on the floor, I still have 163,000 live objects at any given time. The object delta is useful for kind of highlighting how fast you're allocating, how many objects are getting allocated, and then you can see the red is when the GC is going to go ahead and reclaim that memory. And then down below, we have the actual allocations. If you use any tab in this tool, it's the allocations tab. This is the most useful one. And so let's go ahead and let's reduce allocations, because if you reduce your allocations, you're going to improve performance. You're hopefully going to have less impact on the GC, and the GC is going to have less impact on you. And so as I start looking at this, I'm going to start scanning down, and I'm going to look at the allocations that are happening. So the first one I see is system.string. It's got a reference type next to it. That's interesting. I'm allocating 930,000 strings. That makes sense. I'm literally parsing a file, and the file record that I'm getting has a bunch of strings in it. Totally understand. The next thing down is the CSV helper benchmarks file entry. These are the entries that I'm making. I'm making 92,000 of those. Again, that makes sense. I'll have one for every line in the file. The next thing I see is system.double. This is really interesting because what's happening here is this is a value type. And so this means I'm actually allocating a value type somewhere on the heap. Normally, this just gets passed and it would never be allocated on the heap. And so what's actually happening here is we're boxing this double. I don't feel like investigating that quite right yet. So I'm going to keep skipping on. And then the next thing I see is the system.typeArray. And I'm allocating 92,000 of those. So it looks like I'm allocating a new type array for every single entry that I'm enumerating on, which is kind of odd. And what we do in this view is we group all of our array allocations together. And so you can expand that and you can see the size of every allocation. And as soon as I expand that, the first thing I see is system.type 0. And so what that means is I'm actually allocating a 0 length array that holds absolutely no data. I'm allocating an array for every entry that holds absolutely nothing. And if you look at the size, I'm out of a 20 meg file that I'm parsing, I'm allocating 2.2 megabytes of junk arrays. This is something I see all the time. And I make this mistake all the time. And almost inevitably, it's due to trying to fill the contract of some sort of method somewhere. So like I was saying before, we capture every allocation, we capture the size of it, we also capture where it was allocated. So if you double click on the system type array, we're going to paint on the graphs. We're going to show you this is where that was allocated at the time. So you can see we're constantly allocating these things. And we're allocating these in the CSV helper, object resolver, CTOR, anonymous method. I have no idea. So I'm going to right click on this. I'm going to say go to source file, and it's going to send me into the source. Looking at this, I don't really see where I'm allocating a type array. I see no line that says new type array. I'm not really sure what to do here. So I'm going to set a breakpoint. And I'm going to kick it off in the debugger. And so in the debugger, I'm here. I'm going to start walking up the stack. Okay, I see this resolve method. It's got a type that's passed in, so that's interesting, but it was a type array that we were allocating. And it's got this params object array, which seems a little fishy, but I'm not really sure. So I'm going to keep walking up the stack. And as I walk up the stack, all of a sudden I see resolve. And resolve is only passing in a single parameter. Whereas when I go back to here, it was passing in 2 parameters. So somewhere there is a parameter that's getting allocated to fulfill that. And if you're wondering why the tool didn't immediately send me to this source location and instead sent me to something 2 levels deep, remember when we're benchmarking, we're running release bits. And release bits mean we're going to have compiler optimizations that are happening, and the JIT is going to inline a bunch of stuff. And in this case, the JIT inlined a bunch of stuff. We don't have the exact precise source location, but we're engineers. We got tons of awesome tools available to us in Visual Studio. We can set a breakpoint and we can find it. And so, excuse me, if I'm going to go ahead, I'm going to put my cursor on current, I'm going to hit F12. Visual Studio is going to take me to the actual definition of this. I see it's this I object resolver thing. I have no idea what that is. Again, I've never really played with this library. I'm going to click on I object resolver. I'm going to use Visual Studio's F12 again. It takes me to the interface. I go ahead and I scroll down here and I see, oh, there's 2 resolves on here. And this interface actually doesn't provide a resolve that doesn't take in any arguments. This is the aha. This is where those allocations are coming from. And the funny thing is the fix is so easy. The fix is literally just provide on the interface the 2 resolve functions that don't take in any arguments. We go back to that resolve thing. The bottom one where we're resolving with the generic parameter, I'm just going to use type of and pass it on up to the next resolve. And then the resolve that doesn't take in any types, I'm just going to take the one that does take in a type, and I'm going to pass it an empty array. And you might think that, like, hey, we were already getting the empty array before, but what's different here is .NET will go ahead and it'll cache this empty array for me. And so I'll no longer be allocating this every time. If you didn't believe this, or it's a more complex type, another thing that I use all the time is I'll just do like a static empty instance, and I'll just pass that in. And again, we measure, we make a change, we measure again. I've gone ahead, I've measured again. I look at this and I see system type array. In fact, I have to search for it because we're allocating so few, and all of a sudden my allocations went away. And if you look really carefully, my live objects before were 164,000 objects. Now I'm down to, at peak, 156,000 objects. This already is a pretty big win. We're helping not allocate a bunch of garbage for the GC that it's later going to have to clean up for us. And so this is an easy way to try and get performance out of your applications. And so the last thing I want to talk to you about is Copilot. And so we've gone through the tools. I've kind of brought you along for the ride. A lot of times these tools can be a little intimidating. There's a ton of data that's being used. And so we're investing heavily in Copilot to try and help you understand where you can start your investigation. And so in this, let's go ahead. We're going to change from, again, running our benchmarks to we're going to read the large file. We're going to read the large file a bunch of times. The only reason I'm doing this is all of our Copilot scenarios require the source code in the profiler. And again, that's broken right now due to a bug that is being fixed in 17.12, so it'll be out very, very soon. But in the meantime, there's an easy fix, which is just change your console app so that it calls your benchmark a bunch of times. We're going to go ahead and we're going to profile this again using the performance profiler. This time, we're going to use the CPU usage tool again. When you're collecting from that, normally you see a CPU usage graph. And at the end, we're going to get back to our summary view. And so now that I'm here in my summary view, I'm going to look at the hot path, and I have my read, I have my fill buffer async, and I'm going to jump over into the modules view. I can see my CSV helper benchmarks, benchmark, read large file. And so this is the benchmark that I wrote. Remember, I don't know how to use this library. So I went ahead, I copied, pasted code from online so that I could run it and I could use it. Maybe I'm not doing this in the most efficient way. And so now we have this analyze method with Copilot. I can go ahead, I can click that. Copilot's going to help me turn around and optimize that method. And I know you're all thinking, like, Nick, I'm actually not dumb. I could copy and paste code. I could paste it in a chat GPT and I could say optimize myself. The cool part about Visual Studio, and especially with this performance profile, is we're not just telling Copilot, go and analyze this method. We're telling Copilot to go analyze this method, and we're also providing all of the rich context that we have here in this performance report and in Visual Studio. We're passing along this data that says, hey, the most expensive line is line 50 here. It's taking up over 30% of the time. See if you can steer your investigation there. Also consider other optimizations. We tell it to try and pass things by ref. We try and tell it to optimize buffer sizes, all kinds of interesting, cool things. And in this case, Copilot's already called out something that's super interesting. It says you can increase the buffer size of StreamReader to reduce the number of I/O operations. This is awesome, and this is something that was not in that sample code, not something I've tried. So I can copy and paste the code directly from the chat window. You can see it's gone ahead and it's adjusted the buffer size, and it even calls out to me to say, hey, go ahead, adjust the buffer size, play with that. And so now I can go here. Again, I measure, I make a change, I measure again. I'm going to go ahead, I'm going to reprofile this. I'm going to get this. And if you remember back to our previous one, we spent around 19 seconds. We're now spending about 15 seconds overall. If I go ahead, I profile this with benchmark.net, my initial run of this was 142 milliseconds. After adjusting the buffer, I'm down to 133 milliseconds. We've actually made our code 6% faster here, and we haven't really done anything. We ran a performance report. We asked Copilot what it thought. We brought the code in. We measured it again to actually validate what Copilot was telling us. And we found out that we got a good change. This is awesome. This is a great way to learn to use the tools and make you a better software engineer. And so with that, we've done a ton of benchmarking. We've gotten through the CPU usage tool. We've gotten through the .NET allocation tool. And I've shown you some of the Copilot features that we're working on. If I could leave you with any takeaway, it's really to build up a benchmarks artifact in your code, in your repository. These are super, super useful long-term. These aren't just something I add and then I do performance investigations, make a change, and then chuck them out. Again, I really like to think of these as like unit tests. They're useful in the long term. They help you guard your performance. They help you understand what the impacts are of various changes that you're making in your application long term. Use these benchmarks to systematically make improvements. On each of these examples, we measured something, we made a change, we measured it again, and we noticed if we made things better or we made things worse. And then lastly, try out Copilot. You're going to be surprised what it finds out and figures out. We've had a ton of success with it on my team, and sometimes it's going to recommend bogus things. The cool part is if you have these benchmarks, you have the ability to measure the things that it's changing, and you can see, was this good, was this not good? And you'd be surprised at how effective these small changes over time, how they really add up to the impact. It's kind of like dieting. No one goes out and loses 100 pounds overnight. But if you systematically work at it over time, you're going to get faster and faster, and your customers are really going to love it. And with that, any questions? Start there. Yeah, so the question was, is the profiler limited to enterprise? It is not. It is in community. You get all the access to all the same data. In community, if you sign up for Copilot and you're logged in with your GitHub account, you'll get access to that as well. The only thing that's gated in enterprise is our profile unit test. And my boss is not here. And if you really want to profile a unit test, create a console application, instantiate your unit test, and then run it through the profiler. It'll work. Other questions? I saw other hands. Yes. Yes, yes, you can totally run the profiler on just any application. You can run it using the startup project. You can attach to a random exe. You can say launch this exe under the profiler, and you can make meaningful impact. The hard part about that is it makes it harder to make changes and then measure like before and after, because you're like, oh, okay, I profiled for like 10 seconds, and then the second time I profiled for 12, but yeah, I think it's better. That's where the benchmarking really starts to shine, because it's systematic. Like, you should have the same results on the same machine. That's the other thing to also kind of take away from this is like, run on the same machine, try and have most of your applications closed. If you're on a laptop, make sure it's plugged in, because you get drastically different numbers based on the power, stuff like that. But yes, it does let you just attach and run stuff, but I find benchmarking just to be a little bit easier. Other questions? Yes, back there. In a build pipeline. I love it. This is a problem that my team is currently working on right now. We're trying to build out the PR experience for benchmarks. I will say that if you go and if you create benchmarks, you have your benchmark assembly, your DLL, and you have the diagnosers on it, you could manually call benchmark.net, benchmark this in your PR, CI, CD, stuff like that, and it will spit out a diag session, and then you can go and analyze it. The piece that you're kind of missing right there is comparing the two runs against each other and doing it on a machine where stuff isn't going to change. We are in the process of building that out right now. It obviously will not be ready for 1712, but it's something that is coming. Yeah. Any other questions? Yes. I believe I was told that they'll be on the conference website. Come find me afterwards. Harshada, we have a debugger Twitter. We will put an AKA link on the debugger Twitter that has the slides so you can follow along on that. I have a Twitter. I never check Twitter, so, but we'll use that one. Yes. Nice. Not yet. That was someone recommended that I then have a final slide where I was like, and we're going to hit the PR and we're going to push that PR up and then get all of you to upvote the PR. I will be pushing the allocation one for sure. The CPU usage one is a little trickier. I would need to talk to the author because if we have the read ahead buffer in the async version and you call the synchronous version, I don't know if that's currently supported in CSV helper, and that would get weird because then you would have to be like, oh, I need you to flush the read ahead buffer, and you'd have to call like .wait or something, and it would be awkward. That's the only reason why I haven't done that one. I will for sure be doing the allocation one though. Yes. Mm-hmm. Yep. The one that I would go to is this memory usage one. The memory usage one is super useful. We also, if you've ever F5'd in Visual Studio, I hope you have, you'll know the pretty graphs that pop up. That is also my team. That is these tools, they're just running in debug time. I'm hesitant to recommend them as much because, again, you don't have compiler optimizations. That does have the CPU usage tool, and it does have the memory usage tool. The memory usage tool during debug time is flipping awesome because you can hit a breakpoint and you can say, take a heap snapshot. You can then run. You can keep going and doing stuff. You can get your heap to expand. You can take another heap snapshot. And then what that tool can do is it can diff the two snapshots. And so you can see what are the types that actually started to grow, and then how are they rooted? Why can't the GC reclaim them? We are working on that right now. We are jamming Copilot everywhere we can in the tools because we've heard from our customers time and time again, like, I don't want to need a PhD to understand the tools. I want to be able to get into the tools and I need to be able to do my job. And so Copilot's really helping with that, where we can take that trace, we can have Copilot give us some insights, and then we can start our investigation. Yeah. Any other questions? Yeah. On that last frame, that one, yep. It says .NET async. Yes. The reason you didn't use that one? There is. So my team started on the .NET async tool. We started building it out. And unfortunately, it kind of has a fundamental problem, which is it egresses all of the async information through the same stream that we get most of our data. It's called ETL or ETW, event tracing for Windows. Because there's so much async that's happening in .NET, it actually skews the performance of other traces. And so very similar to the allocation tool, we also go through that ETW. We don't let you run any other tools because we know it's going to skew the data. The .NET async, if you're async heavy, it's also going to skew workloads. I've seen it skew it as much as 50%, and it's going to lead you down kind of dubious paths at times. So I don't always recommend using it. We still have customers that use it and they find it useful. So we have left it in. We're currently working with the .NET team, though, to come up with a better way to egress async information. So we could do two things. One, we'll be able to see the impact of like, oh, I made this async call, but how long did it take to actually complete? And then the second thing we want to do is visualizing async stacks. Like I showed you, it kind of flips it on its head, gets super difficult to track down, and it put it back onto the thread pool, which means you'd be kind of going along on one stack. You'd call an async call, and then the continuation of that would be on the thread pool on a different thread, and you'd be going down. It's really hard to understand that. And so the async work that we're doing with them is to be able to establish that linkage so that we can then take that stack from the thread pool thread and then reparent it back where it belongs so it's easier to understand. Yeah. Any other questions? Cool. Well, I appreciate it. Like I said, please fill out the survey. It helps me understand if this was useful and if we should keep doing it. Awesome. Thank you.